Hi, I'm going to show you how to do a few things for Monday's lab here. This is your lab report document. I have not made any changes this time. They give a molecule for you, and in the lab you will use some molecule toys to build a model. You will then sketch the 3D model that you build. You will also draw the Lewis structure, and you will answer this question. I will show you how to answer this. You will give the molecular shape of the 3D model, which I already showed 1.5 lectures ago. I will show you that again here. You will decide if the molecule is polar or nonpolar. I will show you how to decide that in this video. And you will determine whether there is resonance or not. This will be mostly a guess, and your guess is very likely to be correct. You learned how to do this before the last exam. I mean, before the previous exam. Let me go and find a molecule to do for you. I will not use one of these. I will use instead a molecule that is similar to one of these. And the molecule that I will use is CH2Cl2. First, I will draw the Lewis structure. Here is the Lewis structure for it. It does not matter where you put the H's and where you put the Cl's, as long as you put the H's and the Cl's somewhere. And they have to have all of their valence electrons, and the entire model, the entire Lewis structure must have the correct number of total valence electrons, which is 4 for the carbon, 1 for each of the hydrogens, so that's a total of 2, and then 7 for each of the chlorines, and that means a total of 14. So 4 plus 2 plus 14 is 20 valence electrons. So now I'll count the valence electrons to make sure that this is a correct model. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Great. So this Lewis structure is correct, or is likely to be correct. Everyone is following the octet rule except for hydrogen, which cannot follow the octet rule because it is too small. Now, I will now show you the 3D model. You will make this 3D model using some toys in the lab, but I will show you now with some software. And here is the 3D model. The green atoms are chlorine, and the white balls are hydrogen. The sticks here are the chemical bonds, and the gray ball in the center is the carbon. So that is the 3D model for this molecule. Now, you're probably thinking, how am I going to draw a sketch of this model? Let me show you how to do that. I have a bigger version. Here I have arranged this model so that there are two bonds which are flat on the screen. There is one bond that is going behind the screen, and there is one bond that is coming out of the screen, right? So I'm going to draw this line as a line on the paper, this line as a line on the paper, but this line I'm going to use a wedge, and this line I'm going to use a dashed line. I'll show you exactly how that should look. Right, now this is the carbon in the middle. There's a line for the chlorine atom. There's a line for the chlorine atom. And there is a dashed line for the hydrogen atom going into the screen or behind the screen. And there is a wedge. This is a wedge. You must color in the wedge for the hydrogen atom that is coming out of the screen, right? And I'm done. This is the 3D sketch of the toy model that I made. Actually, I didn't make it in this case. I used the software to make it. Sorry. So I used the software. So one more time, this is the line that is flat on the screen. This line is also flat on the screen. This line is going behind the screen, and this line is coming out of the screen. To draw this, I used a straight line here, a straight line here. I used a wedge here, and I used a dashed line here. You can see that again here. I'll move this over so you can easily compare. Okay, you see, stop spinning that. Okay, so here I have drawn a straight. Hey, where's the L? Okay, yeah, that's better. All right, so here is a straight line, and the straight line is right there. A straight line is right there. The straight line means that the bond is flat on my screen, or in your case, it's on your paper. And then the dashed line here indicates that the hydrogen atom is going into the screen or behind the screen, in your case behind your paper. And this wedge here, this triangular wedge, shows that this hydrogen atom is coming out of the screen, or in this case out of your paper. Right? That's how you draw the 3D sketch. Now I'm going to show you how to determine the polarity. Now, there are different kinds of bonds. There are polar bonds. There are polar bonds. And there are nonpolar bonds. And then there are ionic bonds. Right? Okay. An ionic bond is a bond that is between two fully charged things, such as NaCl. This molecule has an ionic bond. In fact, we have seen that the Na has a plus charge, and the Cl is chloride. It is a minus charge, and this compound stays together because of the plus charge being attracted to the minus charge. That is an ionic bond. But the other chemical bonds that we've drawn on paper with the Lewis structure are with these lines. With these lines, remember, the line indicates that there are two electrons being shared between this atom and that atom, the atoms that are on either side of the line. Those bonds are covalent bonds. Covalent means that the electrons are being shared between the two atoms. It is not the case that one of the atoms is plus and the other atom is minus. That is not the case. In the case of the covalent bond, there is no charge here. It is just a sharing of the electrons. Now, covalent bonds come in two flavors, a polar covalent bond and a nonpolar covalent bond. Okay? Let me give you a moment to understand that. The covalent bonds have two types. There are polar covalent bonds and there are nonpolar covalent bonds. Right? Okay. So there are two main bond types, covalent bonds and ionic bonds, but among the covalent bonds there are two more types, polar bonds and nonpolar bonds. Both of those are covalent. Okay. Now I'm going to show you the difference between polar bonds and nonpolar bonds. But that difference comes from electronegativity, which is right here. I'm going to pause this video now.